To introduce our next speaker, I actually had dinner last night with Mark Biagi. Mark is a solution executive with Bentley Systems, and as I said, the most enjoyable dinner with Mark last night. I asked him if he had a quick statement about what was the best thing he's ever done in his working career, and it was quite enticing, quite interesting actually. He mentioned, he may in fact tell you more about this in his own presentation, but he mentioned that he had made a purchase recommendation to his owner to purchase a company. So Bentley as a company is growing by acquisition, and his recommendation to purchase this company was accepted willingly by the company owner, and has actually resulted in a significant strategic shift in the direction and capability of the company. So the person you're about to hear is a man of some considered accomplishment in the industry that he serves. So would you join me in welcoming Mark Biagi? He's going to talk about enhancing the life cycle of your distributed generation portfolio. Thank you, Mark.
Good morning, everyone. Thank you, Mr. Chairman. Ladies and gentlemen, I'm honoured to have the opportunity to present to you this morning. My name is Mark Biagi. I'm the Solution Executive for Power Generation with Bentley Systems. It's my role in Bentley to manage the broad portfolio of products and to define the strategy for how we better address the needs of the power industry. Power infrastructure, by which I mean generation, transmission and distribution. And it's all about how we can better design, build and maintain power infrastructure. Before I get on to the meat of the presentation this morning, I'd like to clear up a couple of things. Because with a name like Bentley, we can often be confused for a couple of our other quite well-known namesakes. For example, Bentley Nevada.
We're not that Bentley.
Bentley Nevada is part of General Electric. They provide vibration monitoring equipment. We have no relationship with them. And the name, if you look carefully, is actually spelled very slightly differently. They have no E. So we have no relationship with them. That's not to say anything bad about what Bentley Nevada does. I'm sure they're very, very good. Nor, as some of you may imagine, are we in any way related to Bentley Motors. We're not a Bentley car company. I can understand perhaps the confusion because Rolls-Royce makes beautiful cars and they are also very much involved in power generation. That's not the same as Bentley. We're not that Bentley. But we do make our own V8 Monster. We have our own V8 Monster, and V8i, we call, is the largest single platform release portfolio of infrastructure engineering applications. And that's plant design, building design, civil engineering tools, electrical engineering tools, and so on. Everything that's required for the design and construction of infrastructure. And we are Bentley.com. We are the original Bentley.com. So, and what is Bentley? So Bentley is a privately owned software company. We've been established for almost 30 years now. The name comes from the family of Bentley brothers that originally set up the firm. We provide a wide portfolio of products, software products and services that are used by around half of our customers are engineering contractors involved in the design and construction of infrastructure, and around half of our customers are owners and operators of infrastructure assets. And by infrastructure, I mean all areas of infrastructure. I mean buildings, I mean bridges, I mean roads, I mean rail infrastructure, I mean water and wastewater networks, I mean city layouts, I mean mining, I mean oil and gas, I also mean transmission and distribution, and of course, I mean power generation as well. and that's going to be the thrust of the presentation this morning. Now, historically, Bentley's origins, like many other software firms in this industry, is from the design world, the computer-aided design world. So we've been known as perhaps the CAD company, and I think that's perhaps a slightly old-fashioned way of looking and defining what it is that we do. Instead, I would prefer to describe what we do as being infrastructure information modeling. It's information modeling of all the different data points that are required in infrastructure design, construction, and operations. So we use information modeling to support integrated projects of multidisciplinary engineers, perhaps working in many different geographies, in distributed enterprises, in large organizations. And they are supporting, these integrated projects then are supporting and delivering intelligent infrastructure. Now, I don't want to talk at a product level today, but I just want to introduce three main platforms on which we build this, because I think it helps explain what we do. First of all, MicroStation. MicroStation is the platform design and infrastructure engineering application on which, on top of MicroStation, we then tailor and develop specific products that meet the needs of particular industries. For example, architecture tools. You may have seen just outside the Marina Bay Sands here, there's a building that looks like an upturned hand. That's just one of the many examples on the Singapore skyline of signature architecture work that has been done using Bentley's MicroStation and building information modeling tools. Also, we develop tools for plant design with OpenPlant. We develop tools for electrical engineering, cable and raceway management, structural engineering. Bentley's the leading structural analysis company in the world today. So lots of different design applications. Next, the second platform I want to mention, we call ProjectWise. And ProjectWise is a suite of collaboration tools that enable multidisciplinary engineers to work together effectively to develop the kinds of complex infrastructure that we all require and that is required in power generation. And these tools enable things like better design review, better coordination of distributed teams, and so on. And the third platform I want to mention, and the one that Graham was alluding to in his introduction, is AssetWise. AssetWise is a lifecycle information management platform that supports the requirements of the information relating to infrastructure assets, from the very initial stages of requirements, licensing, permitting, initial contracts, all the way through lifecycle phases, and then supporting operations, things like records management, information management, integration with engineering tools, integration with other enterprise systems like ERP, maintenance systems. So it's a configuration management platform for power infrastructure. And on AssetWise, then we configure and we tailor AssetWise to the needs of specific industries. For example, in the nuclear industry, we tailor and we configure layers and workflow on top of the information model that support the specific requirements and common workflows of that industry. The ways that they have to do things like corrective action, performance improvement, records management, configuration management, and so on. Now, again, we can describe what Bentley does in the power industry. We have what we describe as scalable solutions. And we can describe these across these three vectors, for example, if I can just describe them. The kinds of type and scale of projects that are commonly executed on Bentley's technologies. Well, at the smaller end of the spectrum, I would take this example. In these examples I'm going to show, I'm sticking entirely to project examples that have been done in Southeast Asia or in the Asian region, because that's where we are. And these projects have come to us from our clients. This is a geothermal power station in Papua New Guinea. It's around 30 megawatts in size. The particular thing there is that there's some custom engineering that's been required, some either custom process, custom structures. In some way, there's a custom element to the way that had to be put together that was appropriate for our plant design tools, and the execution of that project saves a lot of time and energy for that company and a better quality product. Going on to scale, this is a 500 megawatt hydropower station, so quite a small hydropower plant, but in this case, hopefully you can see just a picture speaks 1,000 words. You can see the dam, the access roads, you can see the penstocks, the turbine, the building, you can see the control instrumentation, you can imagine the pipe work, you can imagine the kind of rock excavations and the geotechnical work that has to go into defining the selection of the site for these things, and then how you're going to go around actually designing and engineering, constructing, and then ultimately operating this. It's not only generation, it's also things like large substations. So we have an intelligent substation engineering platform, which is widely. This is one example here, a 500 kVA transformer substation by a design institute in China. And then perhaps at the top end of the complexity, if not the scale, certainly the complexity of nuclear plants, the South Korean consortium KEPCO is pretty much standardized on Bentley's design technology for the APR 1400 plants, which they've built domestically in Shinkooi and various other places in South Korea. And they've now exporting to the Middle East, among other places that I'm sure they have good ambitions to do, and we're supporting them in that endeavor. Then, just to briefly describe the infrastructure disciplines, I'm sure you can imagine, we've already talked, I think, quite a bit about the plant, and I possibly haven't mentioned piping and control and instrumentation, electrical, all those aspects of the plants put together. Of course, for our power plant, structural engineering is important. When we're looking at hydropower plants, that's one thing. We're also increasingly involved in renewable power generation, things like offshore wind turbines. We have the structural analysis tools that support the jackets, the wind and the wave loading, that complexity can be handled in our software. So we're the leading structural analysis company in the world today. Building, of course, in power generation is not such Swiss signature architecture necessarily as the buildings on the skyline of Singapore, but nonetheless there are certain buildings required, and we have tailored solutions for those requirements. Civil engineering, I mentioned, site preparation, road, any rail linkages, those kinds of things, again, can be modeled. And then finally, geospatial networks, things like transmission and distribution, things like corridors for pylons and cabling, and how you're managing vegetation and simple things like that, that actually get very expensive for owner-operators, and we can assist them in how they manage it. And then finally, throughout the asset lifecycle, we're looking at, from the very early planning stages, the contracts, the requirements, the permits, the licenses, managing the information that's required to put in things like environmental impact assessments and all those things that have to be done. And supporting the design phase from the front-end engineering design, from the process design. For example, some biomass plants have specific processes. We were talking to someone earlier that had a particular, I think it was a sewage plant that they were using that for power generation. So particular process requirements that we can then engineer, build up, do the P&IDs, the process flow diagrams, get into then the detailed engineering, the detailed design, then supporting the construction phase, getting into construction with things like work phase planning, breaking down the design of the systems into how you're actually going to put the plant together. And we support many different players in that space. And finally then into operations, and supporting power plant owners as they operate their facilities and ensuring that their information asset remains as valuable as their physical assets. Now we can extend this to say things like, whether we're selling to owners or contractors who's using it. And also we have technologies for both greenfield and brownfield, so there's lots of vectors we can include here. And again, just to reinforce the aspect that we are very much involved in Asia Power, if I can just highlight a couple of examples. Again, these have been provided to us by our clients. This is a balance of plant project for a nuclear plant in China, in Dalian, and again, that was really a plant design project there. We're very much involved in the Chinese hydroelectric power industry with various design institutes. I'll show you a couple of examples, but this is getting to a much larger scale now, several gigawatts plant there. is combined heat power plant from South Korea. And in this case, it's a district energy project where also our tools are used for managing the district heating networks and how they support that, traveling through the complexities of their geography there. So we have specific tools for that. Another large substation engineering project in China. And final example is, again, a nuclear example. This time, this is a nuclear facility. It's a decommissioning project of a nuclear fuels facility. So our tools are involved in the dismantling of the plant. What was the optimum way to dismantle it, to cut and pack and store and filter, and also then for the different waste streams, the information management requirements around the high level and intermediate level radioactive waste that was generated as a result of that. So an entire lifecycle information management system. And again, we've got projects throughout the region. We've got offices throughout the region, offices here in Singapore, in Kuala Lumpur, offices in Beijing, offices in Australia, New Zealand. We've got offices throughout India as well. So we're very much present here, and of course we're present around the world. So that's Bentley. That's our Bentley. But what does this have to do with reliability and maintenance? What's the problem that we solve in the power industry? Well, I think one company that did a good job of defining what the problem is a company called ARC. They're an advisory group, or group of analysts from the US. And it's their job to come up and define these kinds of market aspects. And what they defined was a common problem in the infrastructure industry. And they defined three distinct processes. They talked about infrastructure project management as being one phase, infrastructure asset management as being another process, and infrastructure portfolio management as being a third process. And the problem they highlighted was that during the project management phase, the kind of engineering and so on, there's a specific set of tools and systems and information management platforms that are used to manage that effectively. And the kinds of data points that they're talking about there, CAD models, drawings, schedules, and so on. Whereas in asset management, we move into a different phase and a different set of systems and a different set of technologies for supporting that. And again, a different set of data points. In asset management, you're more interested in procedures and practices, materials, warranties, and so on. And then, in portfolio management, the kinds of decisions that many of the owners and operators here today have told us and expressed again, the kinds of decisions you have to make around whether to buy, whether to build a new plant, whether to maintain, whether to decommission, and so on. So the kinds of forecasts and projections, status reports, histories. And really, so you've got three different processes, three different sets of systems, whereas in fact, there's an awful lot of information that does need to be shared between these systems. And what ARC defined was a new category of information management tools, and they described that as asset lifecycle information management. And we think that very well describes exactly what Bentley is. Bentley provides tools that unite these three things, these three distinct processes. And we have tools that support both engineering firms and owner operators in how they can better support these business processes that they have. Because it's all about information mobility. It's about ensuring that information that's generated during the design phase and captured during the construction phase is available in the operations phase. It's available during maintenance. It's available as you go through the life cycle of complexity of dealing with your plant. It's ensuring that the situation where information is just thrown over at the end of a construction project and chuck over there some big pile of data for you. It's ensuring that instead of that, handover becomes hands-on. It's about ensuring that you put systems in place in these stages of the projects that are going to survive through the life cycle of the project, and ensuring that you're capturing the information you need to safely operate your facilities during the design and construction phases. So, to illustrate this, I want to highlight a couple of examples. I'd like to start again with another hydro power plant example. We work very closely with this company called Biagi Hydro China. This is the front page of their website. Very nice hydro power plants that they do. And this is a snapshot of a page from our website where we highlight many of the different projects that they've used a whole portfolio of our technology to success what's the kinds of things that Hybrid China are doing that are supporting reliability and maintenance? Well, for a start, they're doing things like using the 3D models for maintenance planning. Now, this is an example here of a walkthrough, a fly-through, if you like, of one of the hydropower plants that they designed, showing all the equipment, structures, showing the instrumentation. Of course, you can click on any of those items, you can find out the data behind it. You have a data-rich environment in which to be able to better support this. And I think in discussions with several of you yesterday, we learned situations where you might be working with engineering contractors, but then you are going to be operating the facility. And you need to be able to do this kind of work to be able to access the right equipment and so on. Now, nothing particularly special in that. I'm sure you would imagine this is the kind of thing I was going to show. So what I'd like to do is to extend that a little bit further, and let's think about what's the kind of state of the art about how Bentley can support better reliability and maintenance. We talked about information mobility, we talked about better information reliability for things. Well, one of the things that Bentley can do is pretty unique is the idea that because we understand the overall infrastructure disciplines, the building, the civil, the planning, and so on, the structures, we have technologies that can combine these different elements and the drawings and the data and the models. We can combine these into single self-describing packages we call iModel. Now, it's not only Bentley technology, it's not only Bentley design tools that we can gather together. We make tools available so that all manner of third parties can also describe their data in iModel format, and we can package that up all together in a single self-describing container that doesn't need the applications that generated the data in order to view that. So you're able to review the information in this iModel format without the design tools